Hello, geometry friends. Here we are again doing some more constructions of transformations. Leading up to this day, you've seen some symmetry, and then that symmetry followed with some line reflections notes using a compass. And today we're going to do rotations with a compass. Now, rotations with a compass, I would say take the longest, but for whatever reason, I always feel like they're the most fun to do. So I want to make sure you have your compass and your straight edge out. And then we are going to do some rotations with a compass. All right. So when we look at rotations, that means I'm going to turn something. And when I rotate something, I have to know what center I'm turning around, what's my anchor point for the turn, and how many degrees do I want to turn it. All right. In order to construct rotations, we're going to use this construction, which is the one that we made in the last chapter about constructing a hexagon inside of a circle. When I construct a hexagon inside of a circle, we drew 6 arcs around the edge of the circle. So 360 divided by 6 is 60 degrees. And that means each time we did this, we did a 60-degree turn. So I can use that idea to rotate something any multiple of 60 that I want. All right, so it says using this same concept, we're going to rotate triangle ABC, this one, 60 degrees counterclockwise around point F using a compass and a straight edge. All right, now we're going to do this one piece at a time. So the first thing I'm going to do is I'm going to anchor my compass at F. So put the pokey part at F, and then I'm going to put the pencil part on C. So I'm going to open this up from F to C. And there it goes. And I'm going to draw a circle from F going through C all the way around. Then, once I have my circle drawn, I'm going to move the pokey part from F to C, and I'm going to draw those 6 arcs around as though I'm about to make a hexagon. I'm not gonna, but I'm going to pretend for a second that I'm going to make a hexagon. So 1, 2, keep moving intersections one at a time. 3, this takes forever on the computer. 4, whoop, 5, and then we actually don't need to draw the 6th arc because the 6th arc should pass right through C anyway. So I'm only going to draw the 5 arcs. Now, the question said, take point C and go 60 degrees counterclockwise. So if I think of the way a clock goes, I say, okay, a clock would go around this way, so counterclockwise would be right here. Each arc is a 60-degree turn, so that arc represents C prime. And now I'm going to do the whole thing over again, but I'm going to start at F and go through B. So now I'm going to grab my compass, open from F to B, and do the exact same thing. So draw my circle, whoop, and then I'm going to draw 6 arcs around. But here's the thing, I don't need all 6 arcs. We just realized after doing that first one that I only need 1 arc that's counterclockwise from where I started. So we went 1 arc basically down along the left. So what I'm going to do is I'm going to put my pokey part at B, and then I'm going to bring my compass down here and just draw the first arc, that only one that I need. This is counterclockwise from B, 60 degrees. So now this is where B prime ends up. And then last but not least, I'm going to do A. I'm going to do that in blue. So open from F to A. And other fun fact, I don't even actually need the whole circle. I just need enough of it that I could draw 1 arc. So I'm just going to draw like half of a circle for A. Okay, so there's my circle. And then I'm going to do 1 arc in the counterclockwise direction, which would be right here. And now I have A prime. And if I connect the dots, I have now turned this triangle, which I'll try to highlight to make it a little bit more obvious, into this triangle. And if you look at it, it does look like it turned. All right, we turned it 60 degrees counterclockwise. Now, what if instead of 60 degrees, what if we wanted to do 120 degrees instead? Well, if every arc is a 60, then 120 degrees would be 2 arcs away instead of 1 arc away. All right, so now let's talk notation. So I'm going to scroll down here, and we're going to do some notation fill in the blank here. All right, so big capital R means rotation. Little r means reflection. Capital R means rotation. A letter next to the R tells you your center. That means rotate around C. And this thing right here, which is theta, Theta, that stands for an angle. So when you do a rotation, it's a capital R, a center, and an angle. So the big R means rotation. The C is your center. And your theta is the angle of rotation, the number of degrees you're going to rotate. Okay. Now, in this second notation, which I don't use often, it's kind of function notation for rotations. It says you're going to take P, and after you rotate it, it becomes P prime. So this just means P is your pre-image, and P prime is your image. Now, when I printed this, there was kind of a snafu in the communication between Word and the printer, and it turned my thetas into Qs. I have no idea why, but these Qs down here should be thetas, so you might want to fix that. When theta is positive, when your angle of rotation is positive, you turn counterclockwise. And when theta is negative, you turn clockwise. It's a little counterintuitive, but you just have to deal with it. All right, so this front page is all about understanding the notation and knowing that when you rotate, you draw circles and then draw arcs around the edge to figure out how many degrees you go around. This next page is really about what you can do after you see a rotation has occurred. So quickly, 2 basic properties of rotations. When performing a rotation, the center point remains fixed. In other words, if your center of rotation is a point you want to turn, it just turns on itself and doesn't go anywhere. And then the second bullet says for every point P, it moves the exact same degree along the center. So you wouldn't do like 50 degrees on one angle and 60 degrees on the other. That would be silly. So now when we look down here, we have a rotated image. I have this like, I don't know, Star Trek triangle thing that got turned. Technically, this is called a kite, if you're curious. This thing got turned, and it turned this away. Okay, so I can believe that that's a rotation, and it looks like it got turned about point D. So technically, this point right here is both D prime and D. Started off as D, and then it turned on itself to become D prime. It says ABCD is rotated to form A prime, B prime, C prime, D prime. What is the center of rotation? Well, we just said it. My center is D. Which angle or angles shown can be used to state the angle of rotation? Okay, so here's a new thing. When you want to find the angle of rotation, you make that angle by connecting the pre-image to the center to the image. Okay, so one of the angles we could use would be like angle A, D, A prime. A is on the pre-image, D is the center, and A prime is on the image. So I'm going to connect A. I'm going to do this with a highlighter though. I'm going to connect A to D to A prime. And this thing right here is my angle of rotation. Then it says, what is your best estimate for this angle of rotation? Well, that looks like it's, I don't know, a little bit less than 90, I would say. So I'm going to say that this is maybe, I don't know, like an 80-degree rotation. And we went, let's see, if I think about that and I think about spinning it, to me that looks like it's going clockwise. So you would say this is an 80-degree clockwise rotation, or you could say it's negative 80. Either way is fine. If you just said 80, technically that's wrong because positive 80 means counterclockwise, and we went clockwise. All right, and then it says, does rotations preserve distance? So are those two kites congruent? Well, yeah. Do rotations preserve angle measure? Well, yeah, the first shape is congruent to the next shape. The angles didn't change, so yep. So do rotations preserve orientation? This is something we talked about in the last video. If I were to name ABCD, let's see, if I were to name ABCD, I'm trying to find something that you could see me writing with here. So if I did ABCD, A, B, C, D, if I think about how I'm turning that, that looks like I'm going clockwise around the shape. Now let's do ABCD down here. A, B, C, D, A, B. Yeah, I'm also going clockwise. So our orientation is preserved. And FYI, only, oops, I don't know why I put an F there, only reflections reverse orientation. All rotations are going to have the same orientation. All right, well, what about something on the next page? These M's, okay, one turned to become the other M. So the top solid M turned to the left to come down here, all right? And so if you want to think of that top M like taped to a popsicle stick, and then the popsicle stick turned, what I want to know is where was my finger holding the popsicle stick so that that M turned? To figure out a center of rotation is very similar to finding a line of reflection. Lines of reflection, you find one perpendicular bisector. To find a center of rotation, you need to create two perpendicular bisectors. Okay, and that is what we're going to do. So I'm going to grab my compass, and then I am going to connect A and A prime. Now, you don't need to actually connect them, but you need to identify them and then say, okay, I'm going to find the perpendicular bisector between A and A prime. So I'm going to open this thing up more than halfway. And then I'm going to draw my football. Let me move my face over here. My face is in the way. Bloop. And then I'm going to draw this perpendicular bisector. And then I'm going to do the exact same thing, but I'm going to do it between B and B prime. So let me open this more than halfway. Draw in my perpendicular bisector. And where those two lines cross right here, that is your center of rotation. So that would be the anchor point for like a popsicle stick holding the M that it would turn. Okay. All right, and then down here it says construct the center of rotation and estimate the angle of rotation. Okay, so same thing we've done before. So if I need the center of rotation for these two things, I'm going to just grab 2 points. Doesn't matter which two, as long as they're corresponding. So I'm going to grab C and C prime. And then I'm going to do the perpendicular bisector. So I'm going to open more than halfway and draw 2 arcs so that they crisscross. Here's perpendicular bisector number 1. Oh, that's a little off here. There we go. Now I need 2 other points, so let's do, I don't know, how about E and E prime? I'll do the perpendicular bisector of those. Let's see, so I need to be more, nope, my face is in the way again. Come on, there we go. Open more than halfway from E to, oh, I'm gonna run out of room. Dang it. You know what, I'm not gonna do E and E prime. Forget I said that, let's do B and B prime, because my compass won't fit between E and E prime. So let's do the perpendicular bisector of B, B prime. There we go. Open more than halfway. Draw an arc here. Draw an arc here. Draw the perpendicular bisector between them. Mine's a little off, so let me fix it. There we go. And where those 2 perpendicular bisectors meet, which is right here, that's the center of rotation. Now, this question also asks us to find the angle of rotation. And so to find an angle of rotation, you want to connect a point on the pre-image, let's say B, to the center, to the corresponding point on the image. So this arc right here, that would be my angle of rotation. And let's see, that also looks like less than 90. So let's say this is another like 80-degree angle of rotation. And if I think about that, that's not how a clock works. So this would be 80 degrees counterclockwise or a positive 80-degree rotation. Okay, I think that's the last page of this. It is. So that, my friends, is how you do rotations. So hopefully this made some sense. This is a little bit of a longer video than I normally do, but I wanted to make sure you got it. And now what you're going to do is practice the problem set with this and let me know if you have any questions. Have a wonderful day, and I will talk with you all soon.